Hi students, this is Shivakrishna working as assistant professor Anurag Engineering College. Uh, Already we are completed 2 units. Now we are coming to third unit, that is design of slabs. In this design of slab it is nothing but should be element. It have a greater depth and it was small as compared to its length and width. Slab it should be from floors and roofs of a building. They are assumed to carry uniformly distributed loads, and usually slabs are horizontal except in the case of staircases and ramps of car parks. Next one, slab. It is a plate element. It's having a greater depth and were small compared to the its length. Slabs from floors and roofs of the building, and it should be types of slabs. It should be the slab should be converted into one-way slab and two-way slab and continuous slab. Coming to one-way slab, especially some of the slabs, it should be categorized into flat slabs also. What is the one-way slab? One-way slab, it is supported on two opposite sides. If the slab is supported on four sides, that should be Ly by Lx greater than or equal to 2. Here Lx and Ly is longer span and shorter span of that particular room. Both conditions it is called as one-way slab. If one-way slab, the main reinforcement should be provided on the bottom side of the slab, and here only one side should have to provide the main reinforcement, and another side have to provide distribution bars in that particular one-way slab. Coming to two-way slab, the different from one-way slab to two-way slab is Ly by Lx is less than 2. In this two-way slab, the main reinforcement should be provided along both the directions of along shorter direction and longer direction. The main reinforcement should be provided, and here torsional reinforcement also provided in the corners of a total room, and here does not provide any distribution steel in that particular two-way slab. And especially what is flat slab? Flat slab is nothing but the slab should directly supported on columns without beams. Actually the slab should be depending upon beams. Here flat slab without introducing the beams, the slab totally resting on columns. So this type of slab is called flat slab. Next, coming to continuous slab, in case of large halls, auditoriums, marriage halls, etc., the span of the slab is very long. In the type of slabs, you have to prefer continuous slab. The slab provided over such area is called continuous slab. Here, design consideration you have to apply, that is effective depth. L by D ratio you have to take the reference value. This L by D is equal to 20 into modification factor. This class should be available in IS 456 2000, page number 37, clause number 23.2.1. And based upon the effective span, you have to consider from page number 34, clause number 22.2.2. Here, based upon the supporting condition, type of the beam, the effective length should be vary. That is, for simply supported slab, clear span plus effective depth you have to consider, or center to center supports whichever is smaller. Here 1 and 2 criteria you have to consider the smaller value. In case of continuous slab, if width support less than half into clear span, the effective span is taken as per simply supported beam. If the width of the support greater than half of the clear span, or width of the support more than 600 mm, then the end span of one end fixed and other end continuous, or the intermediate spans are introduced, or clear span have to consider, it should be clear span plus d by 2 and clear span plus half of the supports, which should be lesser value you have to consider here. What is the cover you have to provide to reinforcement? Here, provide the protect steel reinforcement from corrosion. You have to provide the cover, that is the nominal cover, and the thickness of the concrete from the surface of the reinforcement bar to the nearest edge of the concrete is called nominal cover, that is effective cover. The thickness of the concrete from the center of the bar nearest to the edge of the concrete is called effective cover. Based upon the IS code provisions, the IS 456 2000, the page number 46, class number 26.4, the total study about the cover phenomena, the nominal cover should not less than the diameter of the bar. Next one, spacing of the reinforcement. You have to provide on that particular locations the minimum horizontal distance between that is shall not, one is the diameter of the bar if the diameter of the all of the bars are equal, and the diameter of the larger bar if the diameter of that all bars are unequal. In that case, you have to provide the larger diameters length, and 5 mm more than the nominal maximum size of aggregate. Based upon three conditions, you have to lesser value it should be taken as the spacing of that reinforcement, and it should be explained in the clause number 26.3 in page number 45 in IS 456 2000. Maximum distance between bars in tension is main reinforcement that should be provided in that one way slab 3D. D is the effective depth, and 300. In that these two criteria, so you have to consider the smaller value. For one-way slab, we have to introduce the distribution steel. That the spacing of the distribution steel, maximum spacing is provided by depending on these two values, that is 5D or 450 mm. And maximum spacing of shear reinforcement is 0.75D or 300 mm, whichever is smaller value you have to consider in for the spacing. Requirement of the reinforcement for slabs. You have to provide the mild steel bars. Reinforcement shall not less than 0.15% of total cross-sectional area. For taking the deformed bars, it should be 0.12% of the total cross-sectional area. The maximum diameter, how much you should have to provide in that slab, it should be overall depth of the total thickness of the slab 1 by 8 times of total thickness of the slab. Slab design checks. Here we are checking for cracking. That should be page number 46 in IS 456 2000. For main steel 3D or 300, for distribution steel 5D or 450, you have to consider the lesser values. Coming to deflection, in this deflection criteria, allowable span to depth ratio 20 into modification factor, that should be here development length, it should be provided on that case pi sigma s by 4 tau bd. Tau bd, it is the bond stress, and pi cs equal to 0.87 times of fy. Fy, it is the grade of the steel, and pi is the diameter of the bar you have to provide in that particular location. Okay, and development length, it should be m1 by v plus l0. L0 should be how much type of hook you have to provide on that particular location, that is the l0 you have to consider. Here after one way slab, we have to consider for design of two way slabs the difference, main difference between the one way slab and two way slabs. Effective span almost same, that is depending upon the support conditions, like that is simply supported at cantilever or continuous beam. Based upon that support conditions, you have to find out the effective span. After design load, here two types of loads you have to consider here, that is dead loads and live loads. Dead loads means here we have to consider thickness of the slab and width of that slab and unit weight of RCC 25 have to clear. After getting the design load, you have to consider the design shear and moment. Here, depending upon the shear and moment conditions, it should be two-way slab. We have to consider along x direction and along y direction. Alpha x w l x square. It is considered for shorter direction, and alpha x w l x square alpha y w l x square for considered as the y direction. Both upon that both movements you have to consider here, that is along a shorter span and along the longer span. That is should be that mx movement in along shorter and longer directions, it will be seen in the IS 456 2000 table number 27. It should be represented by the formulas. And coming to after finalizing the movement, we have to apply we have to find out the area of reinforcement along the shorter span and along the longer span. Here two-way slab, we both sides you have to provide the main reinforcement only. In the situation you have to find out two moments you have to getting in that particular situation, that is along x direction and along y direction. Based upon that condition only two moments you have to came out from that equation. In that situation you have to find out the area of steel in both directions. Along x direction you have to getting one different value, and along the y direction you have to getting the one different value. After finalizing the AST, you have to check the minimum area of steel, that is depending upon the type of the steel. 0.15% of cross sectional area and 0.12% of cross sectional area. Minimum reinforcement you have to provide for that 0.15 percentage of that cross sectional area of FE 250, like MID steel you have to provide it, and 0.12% of cross sectional area it should be provided for deformed bars, that is Fe 415 bars. You have to check the minimum area of steel. After checking the shear reinforcement also in that particular location, and check for deflection. Deflection means m1 by v plus l naught, it should be l by 300, like all loads acting on that particular material, l by 300 you have to consider 350, and only compressive load it should be acting on that particular pavement particular slab, you have to consider for L span by 250. Here two-way slab, one new element you have to introduce it, that is torsional reinforcement. For lifting the total forces on that each corner, for controlling on that lifting you have to provide the torsional reinforcement. After finding the torsional reinforcement total all details you have to getting, then you have to find out the reinforcement details. After completing the slab criteria, you have to check the serviceability criteria. Why it should be need to the provide, why should need to provide in that particular structure should be designed by limit state of collapse. It should be comparatively smaller sections. They must be checked for deflections and find out the width of the cracks. And excessive cracking of that calls also seriously affecting on the appearance and durability of the structure. And coming to the statement, limit state of deflection, in this deflection place you have to consider two types, that is the short term deflection and one is the long term deflection. These are the elastic deformations that any structure undergoes immediately after it's loaded. These long term deflection, these are over a long period of time, that should be mainly due to shrinkage and creep. The long term deflections are, it should be comparatively using 2 to 3 times of short term deflections. What are the factors affecting deflection that should be involved in? First of all, you have to consider age of the concrete at the time of loading, and the type and size of the aggregates, and watt cement ratio, and amount of compression reinforcement provided in that particular section, and size of the members. You have to following this type of factors, you have to highly influence in that particular deflection criteria. This is the formula for finding the cracking in that particular location. The crack developed when there is increasing the tensile stresses onto this concrete. Cracks basically starting point of failures. We should always maintain the safe zone by limiting the crack width to a maximum 0.3. Even 0.004 mm we exposure condition have to very severe. This is the formula for finding the how much crack width, the width of the crack width you have to find out 3 ACR summation epsilon m by 1 plus 2 ACR minus C minimum by h minus x. Here ACR is the distance from the point considered to the surface, and C minimum is the minimum covered to longitudinal bar, and epsilon m is the average strain in steel, and h is the overall depth, x is the depth of the neutral axis. Thank you guys.